This video will start with question number 11, which is page 3 of the packet, and we'll go to question number 14. So for number 11, the question starts with, let x squared minus 7x minus 60 represent x plus a number and x plus a number, and they're saying P and Q. And all they're asking for is, what do you know about the signs of P and Q? Well, if we have something like 1x squared minus 7x minus 60, what they're getting at is, if you factor this into an x and a number, an x and a number, what do the signs of these two numbers have to be to multiply to make negative 60 and add to make negative 7? Well, the signs of these two numbers will need to be opposite. So one sign will need to be negative and the other will need to be positive. That way, when you multiply them together, you're going to get a negative 60. The larger of those two numbers is going to have to be negative so that when you add them together, you still have a negative number. But regardless, the signs, one sign needs to be negative, one sign needs to be positive. For number 12, the question says, express the area of this rectangle in standard form. Now, area of a rectangle is equal to your length times width. So I'm going to take my length times my width. And for this question, I'm actually going to do my box method to multiply. And when I get my polynomial, if I have any like terms to combine, I'll do that. 4x times x is a 4x squared. 4x times negative 9 is negative 36x. X times 2 is 2x, and 2 times negative 9 is negative 18. Now I'm going to combine my two terms that have alike letters. So my polynomial, my area, will be 4x squared minus 34x when I combine negative 36 plus 2, and then minus 18. And that's the answer for the area of my rectangle. For number 13, the question says the area of the square is given, which is 16x squared plus 24x plus 9. Now they're asking you to find the length of a side. Well, the first thing we need to do is think about a square. In a square, all the side lengths are the same. So my factors from this area, whatever it is, 16x squared, etc., needs to factor into identical factors, which would represent the length of the, width and length of the square, which should be the same. So as I'm looking at this area, I'm kind of thinking to myself, the perfect square trinomial, because when you factor these, your factors are identical. So I'm thinking about, how can I factor this so that these are identical? Now 16x squared, for my factors to be identical here, would require a 4x and a 4x. And my factors of 9, for these to be identical, I'd have to use a 3 and a 3. But what I want to do is check to make sure that my 24 actually works out. Now, if this is a positive 9, these could either be both positive or both negative. But if I have a positive 24, that means these should actually both be positive. Now, I'm going to double check this to make sure that this could work out. 4x times 4x is a 16x squared. So that's my 4x times 4x. Then 4x times 3 is going to be positive 12x. Now my 3 times 4x is positive 12x. My 3 times 3 is 9. My two middle terms do combine to make 24x, which means the side of the square is a 4x plus 3 side length. Now the last question on this page is the area of a rectangle, and they give you 3x squared plus 11x plus 10, and then they tell you the width of the rectangle here has to be an x plus 2. Now there's a couple ways that you can do this problem, so I might actually show you two ways. But as I'm looking here, I'm just going to write down that the area is equal to 3x squared plus 11x plus 10. Now, what you need to see here is that one of the dimensions is given for you. So your 3x squared plus 11x plus 10 has to use this factor 1x and has to use a factor of 2. So what would the other factor have to be if one of the factors given is an x and a 2? So this is kind of how I showed you in the notes, and I'll review that here. X times something, these two have to multiply to make 3x squared, which means that this factor has to be a 3 with an x. And then these two numbers, the 2 times some number, have to multiply to make 10, which would mean this number would have to make a 5 because 10 divided by 2 is really 5. So let's just check to make sure that the middle term actually will come out to be the 11x. I'll show you where that comes from. X times 5 makes a 5x. 2 times 3x makes a 6x, and these two middle terms do check out to be the 11x. So the length of my rectangle is a 3x plus 5. Now here's kind of another way, I guess, of doing this problem, and it would be kind of working backwards from what we did in Chapter 8, Part 1. And when we would factor a polynomial, or when we would, multiply the polynomial, we would give you two of these dimensions, so one of them being an x and a 2, and then the other dimension I would give you, and you'd have to find these 4 terms to combine together to make the area. Now, these 4 terms in your rectangle would look like this. You would be given a square term, which always was in the top left-hand corner of your box, and you would be given a constant term which would always land in the bottom right corner of your box, and your task was to figure out how to combine these two middle boxes, which would end up making this middle term the 11x. So I'm going to kind of work with you here. So if I know x times something is going to make 3x squared, I know that something, kind of like I did over here, these two have to multiply to make 3x squared, which would mean this has to be a 3x for that to work out. And this box comes from these two numbers that get multiplied together. Now, if this is a 2, 2 times what makes 10, this would have to be a positive 5. Now, we can just double check, get our middle terms, and make sure that the 11 works. X times 5 is 5x. 3x times 2 is 6x. These two combined together, again, you do get the 11x. So the side of our rectangle that's missing is indeed a 3x plus 5. Hope you enjoy the video.